enough of the numerator, number of moles of HCl there. So this is one way to look at the molar ratio and determine the limiting reactant. Based on the molar ratio there, based on the given amount, the molar ratio is 1.6 to 1. The required amount is 2 to 1. Or 1.6 to 1 is less than 2 to 1. So in this case, well, we don't have enough of HCl. And therefore, in this case, HCl is going to be your limiting reactant. So this is one way to determine who is the limiting reactant based on the molar ratio, based on the quantities given there. Another way to do it really is that you can calculate for 0.32 mole of zinc, you can calculate how many moles or how many grams of zinc chloride can you get. You can also calculate based on 0.52 mole of HCl, how many grams or how many moles of zinc chloride you're supposed to get. Remember, the limiting reactant is the one that gives you the least amount of product. By comparing the amount of product, you can also determine which one is the limiting reactant. So I try to color code some of the things there, and then grams of reactant versus converted to moles of reactant, and then the moles of reactant converted into moles of product, and moles of product and converted back into grams of product there. And let's do zinc first, well, one at a time there. Zinc, we have 0.32 mole of zinc. Okay, HCl, we have 0.52. We finished this calculation. Okay, now if you have 0.32 mole of zinc, that will give you, based on the molar ratio, each mole of zinc give you 1 mole of zinc chloride. So if you have 0.32 mole of zinc, you will end up with 0.32 mole of zinc chloride. But for the HCl, every mole of zinc chloride requires 2 moles of HCl. So this is the molar ratio coming from the balance chemical reaction equation. Okay, so if you have 0.52 mole of HCl, you can only get 0.26 mole of zinc chloride. 0.26 is less than 0.32. The limiting reactant is the one that gives you the least amount, whether in moles or in grams, the least amount of product. This is the least amount between the two. So you can convert them into grams there. One gives you 44 grams, the other only gives you 35 grams. The one that gives you the least amount is going to be your limiting reactant. That's also going to be the theoretical yield. Theoretically, based on 19 grams of HCl, 21 grams of zinc, you can only get 35 grams of zinc chloride. You can't get 44 grams. Before you get 44 grams, the zinc chloride, hydrogen chloride will run out. When hydrogen chloride runs out, you will no longer be able to produce any more zinc chloride. So that's the essence of the calculation we need you to be able to do. Given a chemical reaction, you have 2 reactants, 2 or more reactants, you have to be able to determine which one runs out first. And there are different ways to do it. And once you determine who's going to run out first, you determine the quantity of the product that can be produced based on the one that's going to run out first. So whenever you do stoichiometry questions there, unless you see the word excess, you always have to do all of these calculations. And that's why I'm trying to warn you. The second exam is going to be calculation intensive, because sometimes you're going to see questions like this, and you can't really finish this question, this kind of question, in 2 minutes. I guarantee you that I will not ask you all calculation questions in the second exam. 25 questions, they're multiple choice. Some of them are going to be definition. And as I told you in this class, definition, dimensional analysis, that's all we want you to be able to do. And you have to be able to do them quickly. Okay, so there will be quite a few calculation questions involved in there, and the questions like this will require more than 2 minutes per question. So you have to know your definition well. Whenever you see a question there, if it's about definition, you should use less than 5 seconds to identify the correct answer, and then mark the answer on the Scantron, and you have roughly about 1 minute and 55 seconds saved for questions like this, because these questions will require longer time to process. All right, so in this case, back to the original question, which one is the limiting reactant? How many grams of zinc chloride can you produce? Well, HCl is your limiting reactant. You can only produce 35 grams of zinc chloride. Okay, so this is the type of calculation that we want you to be able to do. Once again, you see this particular slide, limiting reactants, the one that runs out first, is the one that gives you the least amount of product. Okay, so another related question though is that what happens when a chemical reaction is over? What happens to the leftover reactants there? Well, how much excess amount of zinc is left in there? Well, you can actually quantify that as well by doing the calculation. The total mass before the reaction is 21 grams plus 19 grams. You have 40 grams of mass. Okay, and you produce it along with the zinc chloride that's been produced. You also have hydrogen gas being produced. You can calculate the quantity of hydrogen gas being produced based on the limiting reactant, and the total mass of zinc chloride plus hydrogen gas there, it's going to be 36 grams. So the leftover quantity for zinc would be 40 minus 36. Well, that's 4 grams. Or you can make a comparison. 0.32 moles, 0.52 moles of HCl requires 0.26 moles, half of that, of zinc. And so we have 0.32 mole of zinc available. And the leftover amount would be 0.06 mole. 0.06 mole multiplied the conversion factor, the atomic mass there, and we'll give you 4 grams there. And we did some running there. Okay, so that's another question there. Sometimes when you, and this is especially important if you're running a chemical plant, making something between the two reactants there, when you have the chemical reaction there, okay, and when you're running a chemical plant there, you want to make sure that your most expensive ingredients is going to be your limiting reactant, because you want to use all of them, otherwise it will go to the waste. You waste a lot of money when you do that. So the practical application for calculating the limiting reactant in a chemical plant there is that as a manager, as a running manager there, and you have to figure out the ratio between the two reactants there. Whichever is cheaper, you can dump them in there in larger quantity. Whichever is more expensive, you want to make sure all of those expensive ingredients are being used up when the reaction is finished, so that you have the least amount of waste. And the ideal situation is that you have just the right molar ratio, or slightly more of the cheaper ingredients when you conduct a chemical reaction there. And that way you can guarantee that all of the expensive ingredients are being used, and then you have minimum amount of leftover. Okay, so that's another thing that you want to consider there. Another example, since chem is try, we'll try another example here. So in this particular case, in the industry of semiconductors there, we need high purity silicon. Well, high purity silicon can be obtained from this particular reaction. Silicon tetrachloride reacting with magnesium metal, you end up with pure silicon and magnesium chloride. Okay. Here's a question. If you have 225 grams of silicon, 101 silicon tetrachloride, 101 gram of magnesium, how many grams of silicon can you get? Now the first thing that we need to do is to check the reaction equation. Is the equation balanced? Well, how do we balance it? What do we need to do to this equation to balance it? What number do we need? Well, we have 4 chloride on the left side. We have 2 on the right side.